Get started. I'm sure more people will filter in, but we want to be respectful of everyone's time. So my name is Dylan Agnes. I work for the Integrated Design Lab. I'm a research assistant. I'm sure you're used to hearing Dr. Woods do the introduction, but he's currently preoccupied at this moment. So this is BSUG, Building Simulations User Group. It's sponsored by the Idaho Power Company. We do about 6 of them a year with an additional meeting for the stakeholders to kind of plan out next year to discuss what you guys may or may not have liked, as well as future topics you would like us to cover. But for today, we have Ryan Schwartz from Cushing Terrell presenting on utilizing Grasshopper and Ladybug in early design. Ryan is a building simulation analyst. And, sorry, I gotta pull up. There we go. He spends his days developing energy models and assists design decisions to evaluate building performance. He earned his BS and Master's in Mechanical Engineering from Boise State University. I would say that's usually when we clap, but we're all virtual. So Ryan, why don't you take it from here and tell us about Grasshopper?
Yeah, thanks, Dylan. Hey, everybody, thanks for coming today. I'm gonna kind of walk through this Grasshopper and Ladybug tools and how you can implement them in the design process. If you are already familiar with Grasshopper and Ladybug, then this presentation might be a little, you probably won't learn anything new today, but this is kind of geared toward those that don't have any experience with Grasshopper and Ladybug and would maybe be interested in implementing it in their design process. So with that, today we're going to start off, just do a little brief introduction of Grasshopper and what exactly Grasshopper is, and then move into Ladybug tools and specifically Ladybug, go over some climate visualizations, and then Honeybee for energy modeling. And then we're going to take that energy model we built with Honeybee and show how you can do parametric energy modeling with another plugin called TT Toolbox, and then take those results from TT Toolbox and put them into Design Explorer. And then I'll end with a little bit of a demo, just kind of moving through the Grasshopper space and Design Explorer, just to kind of give you guys a feel for it in real time. But before we dive into the presentation, I kind of wanted to give an overview of where this fits into the design process. So at Cushing Terrell, this is kind of one way we visualize the parts of the building performance analysis process. You've got your start of the project up in the headwaters of the mountain, and you're going to kayak downstream through some rapids into the canyon lands and then into the river valley. And so the early stage is where you see these class 3 rapids, and that's where you have high performance impact. So at this stage in the design process, what you do has more of an impact on the overall final design. And so today, this process kind of fits in 1 and 2, the early design exploration, a little bit of orientation stuff I've included in the model. So we're just hanging out in this class 3 rapids where you can do the analysis relatively quickly and cheaply while shaping the direction that the design moves. So Grasshopper, what is Grasshopper? Grasshopper runs within the Rhino 3D modeling software. It's a visual scripting environment. So the screenshot on the top left, that's a Grasshopper script. And then I've got screenshots of what that in the Rhino space, the representation that comes from that script. And so it's also a platform for many open source plugins that are available. So you can add on plugins into the Grasshopper environment to then be able to manipulate stuff in Rhino and Grasshopper. So what do I mean by visual scripting? Visual scripting, there's no actual coding necessary unless you want to build your own components. It's just you can drag these components, they have the code inside them. So as you can see here, this is kind of a simplified example of this component just takes a number that is degrees Fahrenheit and turns it into degrees Celsius. And so the code that does that is just contained inside the component, and all you have to do is connect the input and it'll spit out the output. And so all you have to do when you're visually scripting is pull these components down, drag inputs, outputs to the next component's input, and you kind of work through. And so it makes it easier for those that maybe don't want to get into the detailed level of actually writing scripts in the code. Kind of lets you manipulate things in that manner. The Grasshopper UI. So I've got Rhino on the right and Grasshopper on the left. And so this is kind of similar, I guess, if there are some of you that are familiar with Revit and Dynamo. It's a similar situation here where Grasshopper is to Rhino what Dynamo is to Revit. And so you've got plugins in Grasshopper. They're kind of on the top. And then within each plugin, I've got quite a few downloaded, but there are component palettes. Inside these palettes is where you can drag components out of. You can find components there, and they're grouped by function. So you can kind of see this is the Honeybee plugin, and like the first few are daylight, and then it goes to some energy ones. And therm is in there. And so you can drag these down onto the canvas, and this is where you do all the visual coding and you connect the strings between components to produce results. And so this is just creating a simple test box. So you enter some dimensions in, the component creates a box, and then the next component, this middle component, splits it into perimeter and core zones, and then creates honeybee zones. And when you click on something in Grasshopper and it highlights green, that also highlights that geometry in the Rhino space. So you can see what you're creating in the Grasshopper space, how that looks visually. So one of the main sources where you can get these plugins is Food for Rhino, and it has apps for Rhino and Grasshopper. Did I do that? I don't know why that's appearing on the screen, but the Food for Rhino is it's an open source. Like all these are free. What's going on? Are you guys seeing red lines on your screen?
Yeah, I am. Did you accidentally click a tool?
I don't think so.
Huh. Can you jump to the next slide real quick? Oh, yeah, they're still there. Maybe stop sharing your screen and then reshare it.
I found it.
Or, oh.
Eraser. I don't know why it was writing stuff, but okay. Oh. Anyway, so let's see. Yep. So anyway, this is where you can access the Ladybug tools. But this space, Rhino and Grasshopper, you can also do like a lot of different disciplines use it. So you can see in the categories list, there's a bunch of different ones. There's, quite a few plugins for architecture, but there's also stuff for dental and footwear and games. So it's a kind of a vast repository of different plugins. So if you're looking to get started with Rhino and Grasshopper and want to try to find some plugins, this is a good spot to check out. So next up, we're going to dive into Ladybug Tools. And the Ladybug Tools are made up of these four main plugins: Ladybug, Honeybee, Butterfly, and Dragonfly. And so this is pulled from the Ladybug Tools website. The description so Ladybug performs detailed analysis of climate data to produce customized interactive visualizations for environmentally informed design. So Ladybug's kind of, if you want to visualize climate in any capacity, create graphs, charts, that kind of stuff, Ladybug's the plugin you want. Honeybee lets you do daylighting simulations using radiance, energy models using OpenStudio, and envelope heat flow using therm. And then Butterfly is the CFD component that's available. and Dragonfly deals with more large-scale climate data, such as urban heat islanding. But today we're just going to focus on Ladybug and Honeybee. So this is kind of how these bugs tie into the other softwares and how they're kind of all connected in this web. So you've got Honeybee and it connects to Radiant, so you can do daylighting, and OpenStudio and Energy Plus, so it can do the energy modeling through those interfaces. And Ladybug, so you can get those visualizations for data, that sort of thing. So it's just kind of a web of, it lets you do a lot of stuff from within Grasshopper. So Ladybug and Honeybee, Ladybug Tools, their component anatomy. You have your inputs on the left-hand side, your outputs on the right-hand side. Code happens in the black box. There's a version number and release date. So this is the most up-to-date version, and this is from the Ladybug, and now it's becoming Ladybug Legacy plugin. There should be a new release of Ladybug and Honeybee this year, later this year sometime. But for the inputs, you'll notice that they have dashes before and after them. And so if it has a underscore in front of it, that means it's a required input and the component will not run unless you have an input connected to that. If it's on the back, it's an optional input. So if it has both, it means it's optional for you to enter something, but it's required to run, so it just uses a default value. So you can change any of these inputs. So in this case, only needed the input data to run because it's the only one with the underscore in the front of it and only in the front of it. So now to look at how Ladybug can do some climate visualizations. First, you need to get some climate data. So this can be done a couple different ways. If you have a URL for an Energy Plus weather file, you can just put that in, and there's a component that'll take that URL and download the file and store it on your system. And it knows where it's stored, so it'll just pull that in into this other EPW component that breaks out all the different data sets within the EPW file. Or if you already have the EPW file stored on your computer, you can just put in that file location connected to this component and you're good to go. So first up, we've got the windrows. There's a component that's the windrows component, and all you have to do is connect the hourly wind direction and the hourly wind speed. And one thing to note is that Energy Plus weather files, the data comes in as metric. So if you want to have the charts display in IP units, then you've got to convert it. And there are components that convert between units that are built into the Ladybug. So in this case, I converted the wind speed from meters per second to miles per hour and put that into the component. And then you just have to toggle on the run it to true, and it'll produce this graph and show you how the wind is over the course of the year and what directions it mainly comes out of and at what speeds and that kind of thing. So it can be helpful for if that's something you need. It can produce psychometric charts. And so you can take the dry bulb temperature from the EPW file and the relative humidity and the barometric pressure, plug all this stuff in. There's a bunch of optional things you can change, such as the metabolic rate if you want to create a comfort polygon on the chart. So in this case, the red outline overlaid on the chart is the comfort polygon for someone typing, and I've put in 2 clothing levels, 0.5, which I think is t-shirts and shorts, and then a clothing level of 1 would be like a 3-piece suit. I believe those are the standards. And so if someone's wearing that, they'd be comfortable inside that polygon. So there's a lot of things you can do. You can customize the legend and the colors of the graph. So a lot of options that can be changed. I just kept this simple. Then we've got annual charts, time charts. So in this case, this is just real simple. Just pulled the dry bulb temperature, converted it from Celsius to Fahrenheit, plugged it into the chart component, and it produced this. So you've got your months on the x-axis and your hours of each day on the y-axis. And so you can kind of see how things change throughout the year. Gives you a good visual. And then Ladybug also lets you look at some renewable stuff. So if you want to optimize solar panel tilt orientation, there's a tilt and orientation factor component, and it produces this chart on the right. And so what you can see here is that it calculates the optimal tilt, which is 31 degrees, 31.5 degrees facing south. So this is for Boise. Gives you a radiation of this. And then I added a surface that's just laying flat on the ground, just looking straight up at the sky. And that's at 87.4 TOF factor. So TOF is essentially the percent of optimal radiation that that surface gets. So if you just laid a solar panel flat, it's going to get 87% of the maximum amount of radiation it would get at that location. So you can kind of use this chart to kind of figure out maybe how you'd want to orient a solar panel and figure out exactly, how much radiation it could get. It'll also calculate total solar resource fraction. If you have some shading data, you can plug that in, and that just determines like how much shading is going to impact that fraction. So I didn't include any shading in this just to keep it simple, but that's also a thing there. I know there are some utilities where you have to have a total solar resource fraction above a certain percent if you want to get their incentive for solar panels. So if you need some resources for Ladybug Tools as you're getting started, definitely check out the discourse. It's a pretty active community. If you have a question, just search for it, and you'll probably find something, someone's already asked it, and you can kind of figure it out from the responses. Or if no one has asked that question, then go ahead and ask it, and you'll probably get a response pretty quick. And then there's also Hydra, which is a bunch of example scripts, and you can go on there and download them. They give you a preview of what the script looks like and the components used in it, and then the output. So I just grabbed the radiation rose example. And so yeah, there's a bunch of those on there. If you were looking to kind of see what Ladybug can do, it's a good place to start. So now we get into the honeybee part of this with the energy modeling. And so this is the overall script that I put together for this example. It works from left to right, and I'm going to dive into each little section, and then I'll pull it up at the end and we can kind of go through it if you guys have questions. So this is a geometry section, and it's kind of the key to modeling with honeybee. You have to get geometry into honeybee zones that then move through. You can set all the parameters later for those honeybee zones, but first you need to get that geometry. So you can do this in a number of different ways. I typically import from a GBXML file. So if you have a GBXML file, there's a component, you just plug in your file path and import it, and then you should get your honeybee zones if everything's created correctly in the GBXML file. Otherwise, if it's simple enough, you can just create the geometry in Grasshopper. So for this example, I just created a simple test box. Just gave it length and width and height over here. And then I did this in feet. And so everything is in metric, so you got to make sure you convert between the two if you're wanting to input something from English units to metric. So I just did a 100 by 70 foot building that's 10 feet high. Creates a box, and then took and added a perimeter zone depth of 15 feet. And this component, it splits it into the perimeter and core zones, and then we run this, and it just creates the honeybee zones from that. And then this is in the corner of the visual representation inside of Rhino. So next, I like to rotate the geometry before I solve the adjacencies. I find that it works a little bit faster that way for some reason. I'm not sure exactly why, but so you can enter in an angle and it'll rotate the geometry if that's something you want to look at. If you already know that the building floor plan is set in a certain direction, certain orientation, then you can just not use this component and skip it altogether. But for this example, I'm looking at a few different rotations as one of the parameters to examine. And then the adjacencies, that just checks to and solves between the zones to make sure that everything that's an interior surface is assigned that and that sort of thing. So after you do that, you can move on to the setting the zone parameters. So this is where you can set the space type. And in this case, I just set everything as an open office, but you could select from the building programs drop-down list. There's, quite a few Energy Plus defaults in there, hospitals, schools, that kind of thing. And within each building program, you have your different zone programs. So like for an office, you have your open office, but you've got closed office, conference room, that's that kind of thing. And so if you want, you can assign each zone its own program. But to keep things simple in the script, I just have everything as open office. So once you've assigned its zone program, you can take it and you can choose if you want to or not assign or modify the schedules. In this case, I just left everything as the default schedule, but you can search for energy through the Energy Plus library using keywords to find schedules, Energy Plus schedules, and then just drag those over as an input if you wanted to change the heating or cooling set point schedule, for example. And then you can also take that, so you just keep dragging the honeybee zones down and go to the loads, and so that it comes with default loads, but you can change them if you want. So I just changed the lighting power density to show an example of that. Changed it to 0.75 watts per foot squared. And I also had to convert here because everything is in SI units, so I needed to convert it to meters, watts per meter squared. And then you drag that down and you can set points if you wish. And so I did that. And then you take those honeybee zones coming out of that have been assigned. They're keeping track of all this information. And so you take it to the next step, which in this case is glazing. You can set your glazing percentage. And you can do this a couple different ways. You can set the same glazing percentage for the whole building, which I did to keep things simple. But if you want, and if your design calls for it, you can set the glazing percentage based on orientation. And so there's a component for that all you do is you plug in your different glazing percentages and then take this and plug it into the glazing ratio. And so then you can see a visual representation of the windows popping up now. So next is the constructions. So in this component that's on the far right, you can assign constructions to your walls, windows, roofs, and floors. And so I built up just little simple constructions for each of those. So for the wall, it's made up of 3 layers, and you can search through the Energy Plus library essentially and find, so I've just looked for wood siding, and it goes through and it finds some material, and so I can just drag that into layer 1. And then for insulation, I just pulled in just kind of a default opaque material, and you can assign all the material properties. And then I added that as layer 2, and then I added some gypsum, just searched through the Energy Plus library, material library, and pulled out the gypsum, put that in, made the wall. And so I did that for all of them. The insulation R values and the window U value, those are parameters that I'm changing for the iterative energy modeling. So you can't see exactly what they are on this, but you can see you can convert from, this is English to SI units again, to make sure I keep everything metric when it's actually going through the simulation. And so next, this is the HVAC system. And so there's a couple ways this can be done. The default way is just to use the set HVAC component that's in Honeybee, and it has a list of HVAC systems that you can pull down. And then if you want to change some details, you can go into the air details, heating, cooling details, and change some of that stuff. So if you're just doing a simple model, you can do that, or you can use another plugin that's tied to the Ladybug tool family, Ironbug, which essentially opens up OpenStudio, and all the things you could change in OpenStudio you can change with Ironbug. So for this example, I grabbed the packaged VAV reheat system, and when you open up that package, it's already kind of like a default predefined package that's already put together. You can go in and you can change any parameters you want in the system. If you want to change something with the air loop, something with the boiler loop, then you can just get in there and anything you want to change, you can change. So this is kind of useful if you want to get into the nitty-gritty of OpenStudio and HVAC system modeling. So once you've set up the HVAC system, you can attach the system in zones. from earlier into this Open Studio plugin or component. And so this is inside Honeybee that it uses Open Studio and by extension Energy Plus to run the simulation. So you can set the simulation settings, set what you want as the output, and then toggle it to run. And when it runs, it opens up a command window and starts running the simulation. And so it can do it pretty quick. I think each simulation in this example for the 5 zones took about 30 seconds on my machine. So it happens pretty quick. And then when you run it, you can see all these outputs on the right-hand side here. You've got your OSM file, your IDF file address, your results file, EIO file, RDD file, HTML. So all the things you're used to when you run an Open Studio simulation, you get these results. And so you can take those results and you can post-process them. They've got components for pulling the result file address, and then it reads that and pulls in the energy usage components. So in this case, I'm just taking what comes out of the model and normalizing the data by zone, so essentially just by square footage. So it turns it into kilowatt hours per meter squared, and then I convert that to kBTUs per foot squared using this built-in component. And then we take that, and it has a header that's kind of describing what that data is, but I only want the numbers so I can do some math on it. So I split the strings at the top of that from the numbers, pulled in this component at the end, does mass addition on all the numbers. So there's a full year's worth, so 8,760 values, and it sums those all up. And then you get, these components, so cooling, heating, that's how many kBTUs per foot square occur annually. And so you sum all those up again and you get the EUI. So just a kind of a quick way to get some energy results. You can also pull from the EIO file and grab, in this example, the zone sizing for cooling and heating. Just kind of grab those as another output. So now that we've run this model, we've built this whole model up, so that does one simulation. How do we do parametric analysis where you want to change one parameter and then see how that changes the energy output results? And the answer to that is the TT Toolbox, which was developed by Core Studio, and which is Thornton Tomasetti, and that's where the TT comes from. And so this plugin, it lets you take parameters that you want to look at, and it'll iterate through each unique combination of those parameters. So in this example, I'm looking at the rotation angle of the building, and I just did 0 to 180 by 30 degrees, but I left out 180 because the building's symmetrical, so 180 is equal to 0 degrees. So I've got rotation angle, window to wall ratio, the glass U value, and solar heat gain, the wall R value, and the roof R value. And so I've got those options listed over here, and that's what's in these drop downs. And each unique combination that totals up to 972 iterations. And so that took about 8 hours to run all of those iterations through this script. So I just left my computer running overnight. And so you can also grab outputs. In this case, I just grabbed those 3 outputs I showed earlier, the EUI and then the zone sizing, cooling, and heating. And you drag those in to this object and make sure it's set to right. And then you let the toolbox fly. And fly just means run, essentially. And what it does is it runs through it, and it takes and writes the inputs and outputs to a CSV file. So you just get left with, what your simulation was because of the inputs, and then you can get your outputs. You take that CSV file and you can upload it to Google Drive. And then once it's on Google Drive, you can get a shareable link from the folder you've uploaded it to. And you take that shareable link and you go to Design Explorer, which is another open source web-based application and it lets you visualize the results of the simulation you've run. So in this case, I've got 972 unique lines, which correspond to each simulation. So that's what this kind of mess is on the right-hand side over here. These are all the simulations that were run with their outputs. And so you've got your outputs in blue text, blue headers, and your inputs have black text, so you can keep track. And so right now, I've clicked on the header over here, and it's coloring this whole thing by rotation. And you can see it's kind of hard to tell. It just kind of looks like a purple mess. There's not much of a distinction. But if we go to the next slide, you can see that I clicked on window to wall ratio as the header. So it's going to color the results by window to wall ratio, where all the simulations that had a window to wall ratio of 40%, they are blue. All the simulations where there was a window to wall ratio of 20% are red. And so you can kind of see a stratification as you'd expect. The window to wall ratio with 40% has a higher EUI because you've got more glazing. And so that's just kind of one, right off the bat, a way to check how much a parameter is impacting the results. So compared to the rotation from north, you can it has much more of an impact and splits out what's using a lot of energy and what's not. So let's say you want to look at which of the simulations are performing the best from an EUI perspective. And granted, you can add as many outputs as you want. You could add a bunch more inputs. You could look at things like daylighting. You could add inputs that are, maybe you want to look at, 4 different floor plans or different massings, different HVAC systems. You could do all kinds of things with this. I just tried to keep it simple. But from an energy perspective, if we just select these lower EUI values, we can see that right away there are a few parameters missing, parameter options missing. So there's no longer a 40% glazing option. If you want to get these lower EUI values, you can't have a 40% window to wall ratio. And you also can't have a roof R value that's 20. It's no longer there compared to here where you had all these options available. And also you can see that the 30% window to wall ratio, it doesn't go to these other glass U values. So you know that for a window to wall ratio of 30%, let's say the architects are like, I can't go down to 20%, it needs to stay at least 30% or higher. Then you can select that 30% and refine that selection even further. And then you can see that in order to do a window to wall ratio of 30%, you have to have a glass U value of 0.25 and a wall R value that's higher than 15, and a roof R value has to be 40. And this is if you want to stay in this lower EUI range. You could bump that up or change that sort of thing. But it's kind of this is just a simple example to show how you can use multiple runs of an energy model where you've just looked at a few parameters and you want to see which ones are impacting the energy model results. So you can kind of try to push the design toward a more energy efficient route. So in this case, you'd want the architects to focus on, higher insulation in the roof and wall and a lower glass U value. But the orientation doesn't seem to matter because you still have all the options for that. So that's that. And now I'm going to just walk through some stuff. If anyone has any questions, feel free to let me know. Let's see.
Hey Ryan,
Yep.
there are a couple questions in the chat. If you want to address them now, or you can wait till after the demo, your choice.
I can address them now. Let's see. Could you comment on whether Ladybug, Honeybee run equally well on Mac version of Rhino? There's no ready to install package on food for Rhino. I do not know. I haven't tried to run Ladybug, Honeybee on Mac, so I don't have an answer for that. I'm sorry. You could check the Ladybug discourse, see if there's an answer there. And is it possible to share the file of this example? Yeah, I can talk with Dylan. Maybe we can put that up somewhere. I can get this file into your guys' hands so you can kind of play around with it. So start off, let me just pull up the Grasshopper. And so this is the script that was shown in the presentation. And it hasn't been run, so it's still at the beginning stage. So I guess one thing, so if you want to select a component, you can go searching for it. So I've got all these, parameters or plugins up here with all their components, so I could go looking for it if I want to try to find it. Or you can double click and it pulls up a search bar, and then you can search in that bar for whatever you want. So like if I want to create a box, it'll pull up anything that has box in the name. So I create a center box, so then it'll instantly populate that in the Rhino space. And if you want to, let's say type in the, like I want to change the dimension of this, you can put in quotes and it'll start a panel, and panel is kind of a way to write text. And so let's say I just want to make it the 25 units in the X direction. You can then drag from that to the component, and it'll just update in real time. So now you've got a box. And so right now it's red in the Rhino space because I don't have it selected, but as soon as I click on this, it turns green in the Grasshopper space, turns green in the Rhino space. You can keep track of which component you're dealing with. And you can turn the preview on and off. So if it's if it's dark, you can no longer see it. You've turned the preview off. If it's a light gray, then it's visible in the Rhino space. So that's kind of a way to keep track of what's visible, and so you can kind of just drag everything and turn those off and on to try to keep track of stuff. So that's just kind of simple ways. There's like lots of little tricks as you're playing with the Grasshopper you'll get to know. But so anyway, just pull up this geometry that was actually in the so this is what it starts with when it comes out of the box. So you can change that, and maybe that'll, actually let me turn what is on. So you can see how up here you have to let Ladybug and Honeybee fly, essentially. But there, I have this, there's a profiler thing, and if you go to preferences, and there's it shows you the time it takes to run those components. So you can kind of keep track if there's like something, one of these components is holding up your workflow, you can kind of see how long it's taking, and it'll color itself differently depending on, so like as you get, this one's 1 second, it's a darker color than this one, which was only 181 milliseconds. If it gets really long, it'll turn orange red, like if it's in the multiple minutes. So just a little tip if you're trying to figure out why your thing is running so slow. So like I can turn this off for now, and it should be pretty fast. So it'll update this in real time. So you can kind of play with these sliders, move things around inside the Grasshopper space. And once you have that, you can turn that off. If I turn this one on and run it, then it should split that previous geometry into perimeter and core zones. And then you can move on. It keeps going through this. Rotate the geometry. Let's say I want to change the angle just to be something random. So you plug that in, and if you hover over these inputs, it tells you, I don't know how easy you guys will be able to see that over the Zoom, but it tells you exactly what you can enter in here. So point, optional rotation axis as a vector, default to z-axis, and that sort of thing. So for this example, or this component, the angle of rotation is in degrees, but sometimes like the default move or rotate objects in Grasshopper are in radians, so you need to be careful of that. So right now it didn't change because I still have this one previewing, but if I turn this one on, it's rotated now. Actually, I turn them both on, they're red, but you can keep track of which one's which by clicking on them, seeing what's green. So turn that off. So it moves through, solve adjacencies. So here's the zone settings. This is what I was talking about, where there are a bunch of different building programs. So there's retail, schools, hotels, warehouse, supermarket, restaurant. And then within the office, there's all these different options, and they all come with their own default Energy Plus schedules. And so you can go in here. I like to keep different colors for my panels that are inputs versus outputs, so I can see which are things that I can change. So as I go through my script, those are options that are available for me to change. So I can zoom in on this. So for wood siding, looked up this keyword, and it goes through, and this is the only Energy Plus material with that. It also looks up constructions, but there are no constructions with that. But I did for the floor, I looked up a very specific construction. And so it goes through this. This is the honeybee call from EP construction library component. And so it looks up that keyword, grabs that construction here, and then I can drag all that up and attach it to the window wall, roof floor, and now you have honeybee zones that have new constructions. So you're kind of just taking a bunch of components that have honeybee zones as their input, doing something to it, and getting honeybee zones out, and then you take those honeybee zones and do something again with them. And just run that all the way through until you get to the energy model, and you have your honeybee zones that you can run the simulation on. So that's the Grasshopper space. All of these drop down, so there's like way more components than it looks like. And so it takes a little bit to get familiar with what's available, but I just suggest getting in there and exploring, playing around with them. And so then there's all these other ones. So TT Toolbox has its own plugins. This is the iterator part of it. So yeah, so that's that, and it hasn't run, but all you have to do, I think it takes about 30 seconds. Just put that on, and it pulls this up. And so it's running that in the background, which if you are used to running OpenStudio simulations, this looks like what you'd expect from that. Yep. Okay, so I see there's another question. Do we have to install TT Toolbox separately? Yes, TT Toolbox is available on Food for Rhino. Should have mentioned that earlier, but you just install that plugin separately. The only default plugins that come with Grasshopper are these first 1, 2, 3, 4, 5, 6, 7, 8 or so, maybe 9. And those are the only default to Grasshopper. Everything else you have to install on your own. Most of them have pretty easy install instructions. It's not too difficult. So now that that's run, you have all these file addresses. You can open up these separately if you would like, and there's actually a component if you want to. So I had that component disabled, so it wouldn't do anything, but you can enable it, and then it'll pull up the location of those files. And so it just runs automatically, and so now this is the file path that I ran the simulation on, and it has all these. This is typical file structure for when you run an Energy Plus model. So you have access to all of those files if you so choose. But for this parametric analysis, don't really deal with that because every time it runs a simulation, it's overwriting the previous simulation. And all you have left of the old simulations is the data that's recorded in the CSV file. So once that's run, you have this set up, and I was just showing this top part before, but you also have access to these pictures, so you can choose if you would like, while you're doing the iteration, to take a screenshot of the Rhino space of what's happening there. So you can see as the orientation changes, the picture changes. And you can also do a 3D image. So if you have like a more complex model that things are changing, this might be more useful. You can just send this, after you've run it, send it to your team and they can explore it on their own. It's just a link that's online. You can get a shareable link. And so you can drag those around, and when you click on it, it corresponds to, it shows you exactly how that line fits on the chart. And you can reorder these columns if you like. You can double click on them and flip which one is which. So if I wanted to move them around, you can do that, and then it repopulates everything. You can do any kind of selection on any of the columns just by dragging. So it's a pretty cool tool for looking at many iterations where it's kind of hard to find those patterns, but you can use this to kind of try to whittle down to what would be a useful for energy, reducing energy, useful components to focus on. And maybe I'll revert that, but maybe you know that the architect, they really want 40% glazing. They're not going to budge on that. So now you can just restrict it to that 40%, and then you could refine. You could run more simulations with the other values and keep that one constant. But if you don't, you can just take this and still look at which ones are the ones that are the most energy efficient. And so it's kind of a cool tool to play with. I can put this link somewhere where I'll talk with Dylan, figure out where we can put all these files and stuff, but you guys can hop on this and play with it yourself. Actually, I can put it in the chat right now if people are interested. So yeah, that's pretty much it as far as the workflow. Just use Honeybee to create your energy model, run that energy model hundreds of times, then use Design Explorer to visualize those results to try to help make design decisions. And you can get as crazy as you want with inputs and outputs. You could try to incorporate some sort of cost component to this as an output where it's going to cost so much more for your insulation or, to upgrade the glazing and see how that, and maybe even do like a cost for the energy. So you can kind of get a feel for how that works. Another question, how do you upload those images to Design Explorer? So those will be written. So if I go back to, in this part of the component, you specify a folder and these image settings. So this image part comes from, this creates the Rhino perspective image, and it's storing these in the folder where it's writing the CSV file. So every time it goes through, it takes a screenshot and dumps that file in the folder, which I could pull up. And then you just put all those online, which actually, for the 3D part, it's a little more complicated. You have to create these spectacle images, these JSON images using the spectacles component. So that's this where you just I took the geometry. So this is the geometry from the Honeybee zone and broke it into its walls, windows, roof. And if you preview this, it puts a color on that. I could turn off the previous geometry. So this is how you get the different colors for the roof and the wall. Scroll all the way back. And so then I just took those colors and assigned the geometry for each of those to these meshes and colored them accordingly. And that's what gets uploaded as well. That's part of this, that's this 3D objects here. And you pull that and take that over to the right component has a 3D objects thing. So it puts it in there and writes it. So yeah, this is kind of this is what it looks like when it writes it to your folder. So you just have a bunch of iterations, and each iteration has its own JSON file for that 3D image and its own picture file for the picture that you see here. So yeah, hopefully that answers that. Are there any other questions? Yeah, I believe so. So question is there a way to view the energy plus errors and warnings after a simulation? So I'm guessing there's an error report. There's an error report in the folder that's containing all this, but also you can take from this README. It pops up what's actually happening when it's running. So you could go through this, and it's got all the warnings in there. So you can scroll through it that way, or you can go find the error report in the folder structure where it's writing this, because all it's doing is creating its own, like an OpenStudio file and running it separately from OpenStudio or from Honeybee. So yeah, hopefully that was helpful for some of you. I just recommend getting into Grasshopper. If you have, Rhino isn't free, so you have to have a Rhino license. Grasshopper is included with that. And then most of the plugins are free, all the ones that I tend to use. So yeah, as long as you have a Rhino license, I'd recommend getting in there and playing around with stuff. And this just barely scraped the surface of what can be done, because I didn't even touch on daylighting or views to outdoors, or there's a few other things that can be done with the Ladybug tools, and there's like CFD modeling. That's like a whole other topic. So it's a wide open world. Recommend diving in.
All right, thank you,